Good morning, ladies and gents, and welcome to Solving Systems with Gaussian Elimination using Matrices. We will also incorporate using technology to aid the process this time. I will go through this pretty quickly in case some of you really got a good hold on this the last time, or at least something similar to it and you don't need a lot of help. For those of you who need to pause a little bit more often, please do so. Jot down some notes and make sure you've got this. You can all do it, no problem. Here we go. Okay, so we have a couple of examples from your notes here, and I picked these because, if you notice, the variables do not necessarily line up. On the left, you've got your 3z and your y lined up, and that's not right. So you always want to think about these in terms of rewriting them. Now this time I did put in the 0y in place of what was missing there and a 0z to line these things up, because when you start to rewrite as a matrix, you want to always be sure you line up your x's, your y's, and your z's. The coefficients of x are 4 and 5. The coefficients of y are 0 and 1. Your coefficients of z are 3 and 0. So be sure you get those lined up. Now then, the choice to put a 0 in there is up to you when you're rewriting the equations. For example, on this second one, I did not add in the zeros. I just lined things up. But whenever I went to write it as a matrix, I put those in there, and you want to be sure that you do that. They have to be there in the matrix form. They do not have to be there when they're in system form, or in this case, expression form. Now let's consider augmented matrices. Augmented matrices are what you use when you're rewriting systems of equations. The others were expressions. They did not have the equal sign. These have the equal sign, so we want to be sure that we rewrite it in standard form. We want all the x, y, z, all the variables on the left-hand side so that it looks like this. When we go to rewrite in matrix form, we call it augmented because it's not just the variables now. You have your 3, 9, 2 that line up with x, negative 4, 3, 4 that are your y variables, or excuse me, y coefficients, and then 2, 0, negative 1. But you also augment it with your solutions, with your answers out there, 7, 3, and 2. That's all there is to an augmented matrix. Gaussian elimination with matrices is pretty much the same as when you were doing Gaussian elimination in the last class with your systems of equations. But with matrices, it's a little bit more efficient, a little bit neater looking, because you do not have the variables written into your equations. It's just in that augmented matrix form to make it easier. Your row operations are still the same. You can trade rows. You can multiply a row by a constant. You can multiply a row by a constant and add it to another row in order to get a 0. Operations are exactly the same. When we look at the examples, I realize that in your notes, reduced row echelon form is first and then row echelon, but I put it here in a different order purposefully because you're more used to seeing the row echelon form, even though you did not know that that's what it was. You're used to taking that 1 in the first equation and using that to get rid of the x in the second and the third equation. With the matrix, you're doing the same thing, but you're trying to get zeros in the second and third equation underneath the 1 from the first equation. Then you move to the next one in that row 2, column 2, and you want to get a 0 underneath it. So you'll do your same, it would be row operation number 3 from up above in order to get a 0 there. And then when you get there, you can see from this that when you have a 1 in the third place, that z is going to equal 6. You would plug it back in to your equations from before and solve to find your x and your y variables. Not a big deal, just what you've been doing. Now when you look at reduced row echelon form, if you notice you've done row echelon form first, but then you start working again and you keep working so that you have a triangle of zeros above the ones, not just below them. And so you would start and use your 1 to get a 0 above it. You would use the in the third row, third column, that 1 down there to get zeros above it. And when you do that, then you'll notice that you can see very easily x is 5, y is 4, z is 6. Now then I want you to realize that you are not going to have to do this form by hand. We are going to do row echelon form by hand, but we're not going to ask you to go back and continue that process because it gets a little bit lengthy. That's where we're going to bring in the calculators here in just a little bit. Okay, so let's solve this one that's an example in your notes. You have x plus 5y equals 7, negative 2x minus 7y equals negative 5. When you rewrite as an augmented matrix, it looks like this. No problem at all. Coefficients of your variables on the left, answers on the right. Now when you look at this though, you know you have a 1 already. That's really nice in that row 1, column 1 position. But you need to get a 0 underneath it. Underneath it is a negative 2. So you need to think, what do I add to negative 2 to get 0? Well, I add a positive 2. So that's what I need to multiply by on the top. So I'm going to do 2 times my row 1 and add it to row 2, and that's going to give me my next row 2. So when I do this, if on the last set of notes, if you looked at the video there, I split it into 2 columns. I'm going to try to get you to do this without having to write things down twice this time. So let's look. The first thing you do is write down that first row. Don't multiply it by 2 and show that. You write the first row down as it is because it's got the 1 there. Now then, think in your mind, I'm going to multiply 1 times 2, that's 2, and add negative 2. That gives me 0. Look back up above. 2 times 5 is 10, plus negative 7 is going to give you 3. Look back up above. 2 times 7 is 14, plus your negative 5, that's going to give you your 9. And so if you can just think through those, you're multiplying 2 times row 1, but you're doing the work in your mind, and then adding it to row 2. Now when you look at row 2, you've got the 0 that you wanted, but you need a 1 in that second row, second column position. To get rid of the 3, you're going to multiply 1/3, or excuse me, not get rid of, but to convert it to a 1, you're going to multiply by the multiplicative inverse, and so multiply times 1/3, and that should give you your matrix right there. Now then remember, when you're doing these, you have to rewrite, because at this point you want to go back in and solve. You've got that y is 3, but you still have x plus 5y equals 7. Take your 3, plug it back in, or substitute it back into the equation above. You get x equals negative 8 and y equals 3, which you rewrite as an ordered pair. Now let's look at this one again. This is an example that's in your notes. If you notice that first equation, when I looked at this, I thought, oh man, it starts with a y. I don't want that. But the second equation starts 1x, and I do want that in that first equation. So my first thought was, I'm going to switch those right there. And I did that just in my mind. I'm not necessarily writing it down, other than I did it to show you, because when I go to write the matrix, I want to be sure that I have that 1 in the first position, because I know I need that already. So 1, negative 2, negative 3 became my first row, and the 0, 2, 1, negative 8 became my second row. Now then from that, I have to stop and think, what is it that I want to get? So I went back and rewrote this next little bit in the way that I wrote the last one, so that you have the writing piece on the left-hand side and the thinking piece on the right-hand side. So when I look at this, I think, okay, I need to use the 1 in the first row, first column, to get zeros below it. That may change other numbers, but my focus is on getting zeros below that first 1. This problem, first column, second row, already has a 0. That's great, no problem. But then I have to look down below that. Move to the third row. If I add row 1 and row 3, that's going to give me the 0 that I need right there. Row 1 has a 1, row 3 has a negative 1. So when I start to add those together, row 1 plus row 3 is going to give me my new row 3. So I'm going to rewrite those first 2 rows as they are. I've already got the 1 and the 0 that I want. And then 1 plus negative 1, and that's going to give me 0. Negative 2 plus 1. I'm just looking at the one above it. I'm not writing all this down. I'm just thinking. Negative 2 and 1 is negative 1. Negative 3 and 2 is negative 1. 0 plus 3, that's 3. So now then I have the 1, 0, 0 that I wanted. Okay? Next thing, when I go to look at this, I think, I've got the 1 in the first row, first column. Now I need a 1 in second row, second column. I have a 2 there. So I'm going to need to multiply by a half. in order to get that to be a 1. So 1/2 times row 2 is going to give me my new row 2. I'm going to just jot that down easily because y'all know how to do that. Multiply all the way through times 1/2 and you get 1, 1/2, and -4 for that second row. Now we've got to get a 0 underneath that 1 though, right? Okay, so when we go to get a 0 under the 1 that's in the second row, second column, then we've got to think, okay, what am I going to do? I'm going to add. No big deal, I have 1 and -1. I can add those together. Okay, should be a simple thing. So row 2 plus row 3 should just give it to me. This is kind of a nice problem. So recopy your first rows. Don't change the first 2 rows because they're just like you want them. But now then start adding the second and third row together. 0 plus 0 gives me 0. 1 plus -1 gives me 0. 1/2 plus -1 is -1/2. -4 plus 3 is -1. And I've got exactly what I want there. The zeros are on the bottom. Oh man, I do not have a 1 in the third row, third column. Okay, so almost done though. I just need that 1 there. So in order to get it to be a 1, I multiply times -2. So -2 on my row 3 is going to give me my new row 3. And again, that's a pretty easy thing. So I just left that there nice for y'all to figure out. Now then, don't forget what you have to do. Go back in, rewrite it as a system, and then I left it for you to solve. You know how to take your z equals 2 and plug it back in order to find your x and your y values. Don't forget to write your answer as an ordered triple though. Now let's look at the special cases. We know that there's infinitely many solutions, no solution, or one solution, but everything we've been doing so far is one solution. Let's look at these now. I want you to pause the video and try to solve these yourselves, and then on the next couple of slides, go down through and check what you've done. Okay, so in this first slide, what I did was just stop and rewrite as an augmented matrix so you can make sure that you started in the right spot. We're going to move to the next one, and I'll show you your answers. Okay, so I've shown you your augmented matrices and then what the solutions are. Now, if you notice, you were getting 1s and 0s, but it worked great on the first 2 rows, and then your third rows were a mess. Okay, the one on the left, you got 0s all the way across. The one on the right, you had 0s and then 2. Okay, this is where it looks different than your other problems. So let's look at the one on the right first, because when you get one like that, it's a little bit quicker to work through. When you get all 0s and then 2 to the other side of the dotted line, you're getting 0 equals 2, which is a no solution problem because 0 does not actually equal 2. That's a false statement, right? So those are the ones you like, you put no solution and you move on. On the left, however, you get 0 equals 0. That's a true statement, which means now you have infinitely many solutions. Now don't forget, from the last lesson, when you were writing infinitely many solutions, you didn't get to just stop there. You had to go back in, you rewrote what you were left with, so x plus 2z equals 5, and then y plus 7z equals 17. Then you solved to find what x was and what y was, and you had to rewrite it as an ordered triple that looked like this. Don't forget to do that. It's not pretty, it's a little messy looking, but now you can plug in any value you want to for z, and you can find an x, y, z value that lies on that in that piece of intersection there. Now then, from there on, you have technology and you have lots of good directions on your notes. So I'm not really going to give you anything else other than I gave you another set of instructions in case on yours you got lost somewhere, because this has pictures of your screens all the way through. So here would be your step 1 where you're going to plug in the matrix that would be, if it's 3 variables and 3 equations, it would plug in as a 3x4 matrix, because you have your rows and your columns. 3 is your rows, 4 is your columns. And so just plug that into your calculator. Here's your steps for step 1, step 2, step 3, And when you get your answer, if you notice on this, I know I went through that really quickly, so you need to, back it up and pause as you need to do this. But like I said, you had your notes, so I wasn't too worried about it. But when you get your answer, it's really easy there to see. X is 5, Y is 1, Z is -2. Write your ordered triple and go with it. So I hope you enjoy the technology piece, because that's a super quick, easy thing to do at the end of this lesson that may have stretched your brain just a touch. So that's all, folks, for this lesson. Work hard, do good.